Hello guys, we're gonna start lecture 33 today, and we're gonna talk about heat equation. In fact, in this lecture, we're gonna see what heat equation is, and in the next lecture, we're gonna solve it. So heat equation, in fact, talks about, so here concerned with the heat transferred by conduction in a rod or thin wire. So here you can see one wire. So suppose you have a thin circular rod of length L. So the length of this rod it's L, starts from 0 to L, and it has cross-sectional area of A. So here you can see the cross-sectional area, and it coincides with the x-axis on the interval of 0 to L. So it starts from 0 and it goes to L. So for this rod, we're gonna see what the heat equation is. But in this lecture, I don't want to talk about derivation of equation. I just want to see what the equation is. In order to derive the equation, we have some assumptions. So we assume that the flow of the heat within the rod takes place only in the x direction. So here you can see that they are in the x direction. The lateral or curved surface of the rod is insulated. So that is no heat escapes from this surface, from the curved surface. No heat is being generated within the rod. The rod is homogeneous, so that is the mass per unit volume or density of the rod is constant. The specific heat and the thermal conductivity of the material of the rod, they are both constant. So if we have these assumptions, we can define a new parameter which is called K. It's small k, which is equal to K capital. Here we define K capital as thermal conductivity divided by rho, which is density of the rod, times gamma. So which is a specific heat, and we call this parameter as thermal diffusivity. So it's a thermal So if we have this parameter, the general form of heat equation is in this form. So the general form of heat equation. So we have K, which is thermal diffusivity, times second derivative of U with respect to X, plus F, which is function of X time U and UX. So I define all these parameters later. It's equal to derivative of U with respect to T. It's the general form of heat equation. So we already defined K. So we said K is the thermal diffusivity. So what's U? U in fact is a function of X and T. So U is a function of X and T. X is location and T is time. So we call it temperature function. So what's F? F is a function of X. So it's the position or location on the rod. T, which is the time. U is a temperature function. Ux, in fact, is derivative of U with respect to X. So Ux, it's equal to derivative of U with respect to X. So f of x and t and u and derivative of u with respect to x, in fact we consider f because of the effect of surrounding medium on the rod. So f is considered to account for the effect of surrounding medium on the rod. So in fact, if we assume that the effect of surrounding medium is negligible, so we can write the heat equation in this form. So I say if effect of surrounding medium is negligible, so then so f is equal to 0, f of x and t and u and to its function of these four parameters, it's equal to 0. And in this case, the heat equation is k times second derivative of u with respect to x. It's equal to derivative of u with respect to t. So now heat equation is this form. So it's a heat equation. In the next lecture, first we talk about boundary condition, and then we talk about the initial condition. And when we have heat equation, boundary condition, and initial condition, we start solving a heat equation.